Apart from the buzzword, DevOps holds a unique position in the software field. Even though many technologies evolved over time and vanished, this path doesn't seem like it might disappear very soon. People from all sorts of professions are willing to get their hands dirty and make a shift to this career. And one thing is for sure, DevOps is here to stay. And we will witness a large number of companies embracing this approach sooner or later. Having said that, I welcome all of you to this session on DevOps, and today we're going to discuss your roadmap to learning DevOps. But before we begin, let's look at our agenda for today. So, first of all, we're going to start out by introducing you to DevOps. We are going to talk a little bit about the necessity of DevOps and why a lot of the big companies are making the shift. Then, we are going to one by one cover in particular order the concepts you need to grasp, the skills you need to acquire to have an industry ready career in DevOps. We're going to talk about Python scripting, operating systems, how to set up your machine, setting up the environment, your server, so on and so forth, configuration management and change management, CI CD tools, as in continuous integration and delivery tools, monitoring software and automation, and finally, cloud platforms, before concluding with our final roadmap. So, without much ado, let's get started. So, what exactly is DevOps? Now, this is an approach that emphasizes communication and learning from a technical standpoint between software developers and IT professionals, like dev as in development and ops as in operations. So, apart from the collaboration of these two teams, DevOps also includes managing production environments while automating the deployment of software and infrastructure changes with utmost care and collaboration. At its core, DevOps means combining development and operations, as I had mentioned before, into one unified team. Through this, you get that continuous process of learning, knowledge sharing, and shared responsibilities that happen seamlessly between these two teams. This idea grew out of the agile methodology and first gained attention somewhere in early last decade. Now, it's not really a surprise why does a company need DevOps? Many departments in companies and enterprises are usually siloed and carry their own procedures, especially when it comes to a software powered organization. The developers will have no idea what is happening with the operations team and vice versa. And it creates a lot of confusion amongst teams and impacts the overall growth of the enterprise and individual productivity. The idea of DevOps is to bridge the gap between the development and operations teams to support other departments and in turn each other. It's kind of like having a 50-foot top view of what is actually happening in this entire cycle. So the workflow within the organization is smooth. Now, this allows the companies to fail early and learn early and thereby quickly deliver software features and security updates. The ultimate goal here is basically to bring products or newer version of the same products faster to the market and with more quality and reliability. Now, one thing that I would like to make very clear right at the beginning is that DevOps is a cultural phenomenon rather than an individual job role. It's more of a team sport and cannot be done alone, kind of like field hockey and football. So try to approach this more as a practice or a system or an approach rather than a set of tools and technologies that you have to learn in order to get a job. But having said that, the understanding of certain technologies and tools such as Docker, GitHub, Kubernetes, Ansible, and Puppet, etc., is very necessary because that is what the companies are looking for when they are hiring somebody in various DevOps job profiles. But most of all, it's about learning the culture and the framework rather than tools. Now, a short summary of what you should know when you are planning to work in a DevOps environment includes a basic knowledge of scripting, programming, and framework. People coming from other departments to DevOps should understand what developers are trying to do in the development phase and then how they are managing the versions of their code, testing and integrating them as well as deploying them to the servers. And finally, how end users are getting the software to use. Once they understand how things are done theoretically and manually with no automation tools, the concepts will get clearer and easier with time. A DevOps engineer not just writes code or automates, but also has to know other related aspects such as scripting, Linux, knowledge of different cloud providers, how the software development lifecycle works. It is also appreciated to have some familiarity with source control and versioning, understanding about infrastructure as code. All in all, the knowledge of DevOps pipeline and how it works, along with the tools which are involved in this particular pipeline, are always going to give you an edge in this cutthroat job market. Understanding of different DevOps success metrics like deployment frequency, lead time to change, change failure rate, time to restore services back, etc., is what you will be responsible for when you work in a DevOps environment. So, where to start your DevOps journey? The problem is that very rarely companies hire freshers to work as DevOps engineers. But that being said, there is actually a huge skill gap in the industry. Firms struggle to hire good DevOps candidates and they often fail because of the scarcity of talent. So, while casually surfing through the internet, I came across this excellent page, the link to which I'll give in the end, which shows a couple of very useful roadmaps for web development, for full stack development, and DevOps engineer. It's really good in any sense and does not only highlight what is the role, but also talks about tools and technologies that you need to learn to cover the area. On top of that is extremely visually appealing, so you can just take a printout of it and stick it on your desk for easier reference. But though the roadmap is good and gives you a sense of what you should learn, it doesn't tell you how to learn and where to learn it. So, in order to complete that roadmap, we are going to go step by step and find out how you can learn the essential skills required to ace the game in DevOps. First of all, is more of a prerequisite, which is scripting. Obviously, and I assume that all of you definitely know that this was about to come. Now, if you didn't, don't worry. Now, you can learn a choice of languages, though I would strongly suggest that you learn at least one of the major general purpose programming languages. My bet is on Python because it is one of the easier ones to learn. A programming language will basically enable you to interact and manage the system resources, such as device drivers and memory devices, and also write software. A well written piece of code will be more versatile, portable, error proof, scalable, and optimized. And it's going to enhance your DevOps cycle, letting you be more productive with a high quality product. You may have to use many softwares and plugins for your CI/CD pipelines, which we are going to discuss further in this session. And you will be at your best if you have a good grip on a general purpose programming language. Like I've mentioned earlier, Python is easy to learn, interpreted, high level, and a powerful programming language with an object oriented approach, which is kind of ideal for infrastructure programming and web development due to its ease of use and very clear syntax. Though later in your DevOps journey, you will have to learn Java, which is also an object oriented general purpose programming language, which is synonymous with your containerization philosophy. So, the next thing we need to talk about is different operating system concepts. Now, this is where the ops of the DevOps part comes in. Now, had it been a couple of years earlier, this part of the session would have been solely targeted towards support guys and sysadmin people who were responsible for knowing about operating systems and hardware. But with DevOps, now even the developers need to know about them. You must be able to write code that can interact with the machine resources and have a sound understanding of the underlying operating systems that you are dealing with. So, knowing the OS concepts will help you be more productive in your programming. Now, this gives you the ability to make your code faster, manage processes, interact with the input output devices, communicate with other OSs, optimize the processing usage, memory usage, and disk usage of your program. Now, as a DevOps engineer, with infrastructure role, setting up and managing servers, controllers, and switches becomes easier if you understand the resources, processes, and virtualization concepts extremely well. Now, to be able to administer the users and groups, file permissions, and security, you must know the file system architecture extremely well, along with essential OS concepts, which include, first of all, kernel management, which is the core element of any operating system. This connects the system hardware with the software and is very responsible for the memory storage and process management. Apart from this, you also need to understand memory management, which is responsible for the allocation and deallocation of the system memory to various system resources to optimize performance of the system. Then you have device drivers management, which is a software program that controls the hardware device of the machine, as well as resource management, which again refers to the dynamic allocation and deallocation of the system resources, such as the kernel, CPU, memory, disk, and so on. Then it's also important to have communication between various input and output devices connected to the machine, such as the keyboard, mouse, disk, USB monitors, printers, so on and so forth. So you have to understand input output management. Now, every program that executes a certain task is called a process. Now, each process utilizes a certain amount of computational resource. Now, the technique of managing various processes to share a load of memory, disk, and CPU usage, as well as the inter-process communication, is termed as process management. Then you also have to learn threads and concurrency along with virtualization and containerization. Now, this concept of simulating a single physical machine to multiple virtual machines or environments to optimize the use of resources and to reduce the time is basically virtualization. You need to understand this well, as you will often need to replicate the real time environment. Now, Linux containers are a great concept to isolate and package an application along with its runtime environment as a single entity. Runtime environment includes all its dependencies, binaries, configuration files, and libraries. And Docker is a containerized command line tool that makes it easier to create, run, and deploy applications with containers. Now, using both virtual machines and Docker together can yield better results in virtualization. Then finally, you have the file system architecture and the distributed file system. An architectural layout of how and in what hierarchy the data is organized on a disk will make your task of managing data so much easier. And in a client server based application model, your client machine will have access to the data located on your server machine through distributed file systems. Now, for a DevOps guy or girl, it's really important to have a good command in the CLI, and knowing bash scripting or shell scripting and networking commands is extremely crucial. You can go ahead and check out our Linux admin certification training, which will provide a good refresher to both beginner and experienced Linux users. The next thing on your roadmap will be setting up the machine, as in what is and how to set up. Now, as a DevOps champion, you should know what is setting up your machine and how you can set it up. Only then you can think about automating it. Now, in general, you should know how to set up a web server like Nginx, Tomcat, and Apache, and also know about caching server, load balancer, reverse proxy, and firewall. In a highly connected network of computers, it becomes essential to understand the basic concepts of networking and how to enforce security and diagnose problems. As a DevOps engineer, you will also be required to set up an environment to test networking functions, in addition to setting up continuous integration, delivery, and deployment pipelines for network functions. So make sure you learn the basic concepts like DNS routing, IP addresses, firewalls, and ports, basic utilities like pings, SSH, netstat, load balancing, and TLS encryption. And also understand the basic protocols and standard rules for networking, such as TCP/IP, HTTP, SSL, SSH, FTP, etc. Configuration management tools such as Ansible and Jenkins can be used to configure and orchestrate these network devices as well. Now, the next thing is probably the most important if you want to get into DevOps, and this is also the most vast area of this particular roadmap, to learn infrastructure as code or configuration management. Now, the IAC configuration files are used to build CI/CD pipelines. It enables DevOps teams to test applications or software in production like stable environments quickly and effortlessly. Now, these environments with IAC are repeatable and prevent runtime issues caused due to misconfiguration or missing dependencies. Now, basically, IAC is to define and manage the infrastructure resources programmatically by writing code as configuration files instead of managing each resource individually as a developer. Now, these infrastructure resources, both hardware and software, may be set up on a physical server, a virtual machine, or the cloud. It defines a desired state of the machine and generates the same environment every time it's compiled. But what does it actually do? Basically, this is responsible for three things: automation, versioning, and elimination of manual errors. Now, here, automation will reduce the overhead and the time spent, and by eliminating manual errors, your productivity will obviously increase. But the most important part here is configuration management or versioning. Now, IAC is a text file which can be version controlled, and this again leads to three things. Firstly, your infrastructure changes, such as scaling up or down the resources, or changing and updating your resources, such as your file system or your user management, can be tracked through versioning history. Second, your configuration files are easily shareable and portable and are checked in as source code. And finally, it can be easily scheduled to run in a CI CD pipeline for server management and orchestration. And to do so, you use tools such as Puppet, Ansible, and Chef. Now, there are more, but we are going to look at these three. Now, Puppet is a configuration management tool to build, configure, and manage infrastructure of physical and virtual machines. Ansible is also a configuration management, deployment, and orchestration tool. And finally, Chef is a configuration management tool written in Ruby and Erlang to deploy, manage, update, and repair server or any other application to any environment. So the next thing in your roadmap is CI/CD tools. Now, this is another very important thing in the roadmap, which is to set up a pipeline for continuous integration and delivery. Now, there are a lot of tools in this section, but I strongly recommend learning at least Jenkins, as it is the most widely used and probably the most mature CI/CD tool in the market. Now, this is an open source automation server and it uses Jenkins plugins to automatically build, test, and deploy the source code. Now, Jenkins is a self contained Java based program, and that makes it extremely easy to configure, very extensible, and well distributed. Apart from that, you can also look at some other tools like the GitLab CI, Circle CI, and Microsoft Virtual Studio Team Services. But Jenkins is by far, to my knowledge, the most popular and widely used tool with numerous flexible plugins that integrate with almost any CI CD toolchain. Also, the ability of Jenkins to automate any project really distinguishes this tool from the others. Hence, it's highly recommended to get a good grip of this tool as a DevOps practitioner. Moving on. Now, it is extremely crucial to continuously monitor the software and infrastructure upon setting up a CI CD pipeline to understand how well your DevOps setup is performing. Now, also, it is extremely vital to monitor system events and get alerts in real time. A hiccup in the pipeline, such as an application dependency failure or a linking error, or say the database has a downtime, must be immediately addressed, notable, and taken care of. You, as a DevOps practitioner, must be familiar with monitoring tools. Now, one of the very popular ones is Nagios, which is an open source software application that monitors systems and networks and infrastructure and generates logs and alerts. Apart from that, you can also take a look at Prometheus, which is also an open source real time metrics based event monitoring and alerting system. And finally, as the computational need increases, so does the demand of the infrastructure resources. Now, cloud computing is a higher level of virtualization wherein your resources are outsourced on a cloud and available for a pay as you go basis over the internet. Now, some of the leading providers are, as a lot of you might know, AWS, GCP or Google Cloud, Microsoft Azure, just to name a few. And they will provide varied cloud services such as infrastructure as a service, platform as a service, and software as a service. So, begin part of a DevOps practice, you will often find the need to access various cloud services, say for infrastructure resources, production like environment on the go, for testing your product without having to provision it, to get multiple replicas of the production environment, to create a failover cluster, a backup, and recover your database over the cloud, and various other tasks. Now, there are three cloud providers that I would like to talk about in particular. First of all, you have Amazon Web Services, which provides tooling and infrastructure resources readily available for DevOps programs customized as per your requirement. You can easily build and deliver products, automate CI CD processes without having to worry about provisioning and configuring the environment. Edureka also provides the AWS Certified DevOps Engineer, which has been designed to help you as a DevOps practitioner in developing advanced technical skills needed to successfully attempt the AWS Certified DevOps Engineer examination. Apart from this, you can take a look at Microsoft Azure as your cloud service provider to create a reliable CI CD pipeline, practice infrastructure as code, and continuous monitoring through Microsoft managed data centers. And finally, you have your Google Cloud Platform or GCP, which uses Google managed data centers to provide DevOps features like end to end CI CD automation, infrastructure as code, configuration management, security management, and serverless computing. Now, all of these are great platforms, but my recommendation to you would be to start with the AWS as it is the most versatile. Let's take one final look at the roadmap that we have come up with. So basically, you start out by Python scripting, which I strongly suggest serves as a good programming language to begin with, otherwise, as well, and serves as a prerequisite in this roadmap. Then you move on to operating systems. My advice to you would be to learn to live in the terminal for a while, knowing some Linux shell like Bash, K shell, or C shell, and understand the tools and networking commands is extremely critical. It's important to have a good command in the command line. Then, as a DevOps practitioner, you need to know how to set up your machine and environment and learn how to set up a web server, along with concepts such as caching your server, load balancer, reverse proxy, and firewalls. Then you move on to learning infrastructure as code. You must learn about infrastructure provisionings, configuration management, version control, and containerization, followed by the very important CI CD tools. Here you can look at many tools such as Jenkins, GitLab CI, and Circle CI, experience with building tools, understanding the concepts of CI CD, the knowledge of a pipeline and how it works, so on and so forth. Moving on, you'll need to know the tools to monitor software and infrastructure, which, apart from setup and deployment, is another important aspect of DevOps. And there are a lot of tools to choose from, like Nagios, Icing, and Datadog, and you can choose one depending on the one your company uses. Sooner or later, you will have to move your application to the cloud, hence, it's important to at least know about some of the popular providers and their basics like AWS, GCP, and Azure. Concluding, I'd like to say there is a good chance that you may already know most of this stuff, and there are a lot of useful resources that you can use. At the end of the day, you should have enough knowledge and experience to bag the job of your dreams. But if you're just starting out, I'd like to say hang in there. It's certainly not going to be easy, but following a set roadmap and guide, you are one step closer to becoming a DevOps practitioner that you always wanted to be. Mastering DevOps opens up the door to new roles and challenges for you to learn and grow. You can become a technical evangelist, a code release manager, an automation architect, an experience assurance, a security engineer, and last but not the least, the job role you've been waiting for, a DevOps engineer. And always remember, DevOps channels the entire process right from the idea on a whiteboard until the real product is in the customer's hands through automated pipelines. I'd like to leave you with that thought. My name is Upasana. Thank you and have a great day.